Hi, and welcome back to Periodic Trends 3.1 video. This is part 2 of 2. In part 1 of what we have already talked about is the history of the periodic table and introduced you to Dmitry Mendeleev and his contributions to the periodic table. We also looked at what are periodic trends, and we started defining some of them. We have covered so far the quantitative periodic trends, so those are the periodic trends that have numbers associated with them. And in part 2, we're going to focus on the qualitative periodic trends. So the first qualitative periodic trend has to do with metallic versus non-metallic character. So I want you to take a second. You already know that the periodic table is sort of set up in this way where metals are on one side and non-metals are mostly on another side. As you go across, I want you to identify what increases. So as you go across a period, does the number of metals or non-metals increase? All right, how about as you go down, what increases, the number of metals or non-metals? Great, so as you go across, the number of non-metals increase, and you can see most of the non-metals are on the left-hand side, and most of the metals are on the right-hand side. And as you go down, the number of metals increase. So especially if you look at something like group 14, it's very clear to see at the top you have one non-metal, and at the bottom you have two metals. So the idea being that most of our metals are going to be on the left side and down, and most of the non-metals are going to be on the right side and up. We can use that understanding of where the metals and non-metals are to help us think about which elements has the most metallic character, means it's the most metal, and which ones have the most non-metallic character or is the most non-metal. So that's what I want you to think about here. Which one has the most metallic and which one has the most non-metallic character. So what I'm going to ask you to do is I want you to identify on this periodic table, so you're going to find this section of your handout, I want you to put a box around the element that has the most metallic character based on your understanding of where the metals are and where the non-metals are. Which element? Is it this one, for example? Is it this one? Has the most metallic character? You're just going to put a box around them. And then do the same thing for the one that has the most non-metallic character. And then we're going to come back together. Okay, so for the most metallic character, it's going to be the element that's in this corner here, cesium. And the reason for that is because as you go again to the left and down, you have the most metals, and so this one will have the most metallic character. On the other hand, for the non-metal, you may have chosen helium because you're thinking, oh, this one is the most up and the most right as your non-metal, but actually it turns out it's fluorine. And what you have to think about for this is for group 18s, for a lot of the trends like electronegativity, if you remember the electronegativity trend, this group has no electronegativity. And we're not going to learn about why in this video. You will learn about why later, but we sort of stop at group 18. And so for the most non-metallic character, it's the element in the upper right corner of group 17, and that will be F, or fluorine. So these are the elements that have the most non-metallic and metallic character, and these are the ones you should have boxed. So if you haven't boxed those, please make that correction. Now, the reason why it's important to know which elements have the most metallic and non-metallic character is that helps us to sort of ground ourselves in other trends. And we'll talk more about that later, but let me just give you an example of that. Metals typically like to give electrons away when they form bonds. And so, therefore, metals, if you go back to our definition of electronegativity, they're going to have a low electronegativity because they like to give the electrons away, whereas nonmetals like to take the electrons. So they're like stronger, pulling the electrons toward them. And so they're going to have a higher electronegativity. And by knowing where the most metallic and non-metallic elements are, well, that may help you memorize the trend of electronegativity. So if you go back to your electronegativity trend, you know that it increases going to the right. And that's where you find the most non-metallic character, and nonmetals have a greater electronegativity than metals. And electronegativity decreases as you go down, and that's where you have the most metallic character, and metals have a low electronegativity. So that's sort of just helpful in terms of keeping track. And we'll utilize that more later to help us memorize these trends. The last qualitative trend we're going to look at is reactivity. And so what I want you to do here is I want you to study this image. This image comes from the class textbook. And you'll notice that in this image, it's pointing out which elements are the most reactive. So take a moment and see if you can identify where are the two most reactive elements. And in the same way that you did before, where you put a box around the most reactive elements, I want you to put a box around, most metallic and non-metallic elements. I want you to put a box around the most reactive elements. Great, so as you can see in this chart, the most reactive elements are the upper right corner. Again, we ignore group 18 because group 18, or they're calling it group 8A, they're very unreactive. And unreactive elements here are shown in blue, and reactive elements are shown in this yellow-orange color. The other one that's reactive is this one here in this group. Okay, so these are the two most reactive elements. All right, now what I want you to do is I want you to compare the two most reactive elements to the most metallic and non-metallic elements that you discovered in the previous slide. So what do you notice, and what conclusions can you draw? Great, what you should notice, hopefully you'll notice, is that the most reactive elements are also the most non-metallic and metallic elements. So can you draw any conclusions from that? What conclusions can you draw from the fact that the most reactive are the most metallic and non-metallic? One conclusion that you may draw is that the more metallic something is, the more reactive it is. The more non-metallic something is, the more reactive it is. So what you'll notice with these qualitative periodic trends, because these periodic trends have no numbers associated with them, they're just qualitative, so more or less, is that instead of going just straight across and straight down, they kind of go at an angle, like sort of corner to corner. So you're increasing your reactivity and metallic and non-metallic character as you're heading towards these two very important corners of the periodic table. All right, now that we've looked at all of these trends, we're going to talk about why is this important. So why is this important? You may remember from the previous unit that molecular covalents, which are molecules made up of all nonmetal atoms, can either be soluble or insoluble in water. So without testing it, how would we know? Like if we're given a chemical formula like C18H32O2 or C12H22O11, how do we know which one it will dissolve in water? The periodic trends help us to be able to determine the way that these atoms would bond in a molecule. So for example, you can utilize information like this to predict one bonding structure would be the one that's shown here. And by the way, in this notation, the corners, at these corners, those are carbon atoms. They're not drawn in. And there's also hydrogens that are invisible. But this shows how these atoms are connected. You could also determine from this chemical formula that this is the structure that would form. So again, from the periodic table, you can utilize this information to develop the bonding structure of a molecule. From the bonding structure, you can then determine sort of this three-dimensional structure or shape of the molecule. You can predict that. And then once you know that, then you'll be able to predict that, oh, this molecule here, which has this long, floppy carbon-hydrogen chain, probably won't dissolve in water. And this molecule is a molecule that's found in vegetable oil. Whereas this molecule here, which has a bunch of OH or hydroxide groups, probably will dissolve in water. So all of this is to say is that the periodic trends help us to predict the bonding structure and then the three-dimensional structure, which can later help us predict certain properties of molecules. In addition, the periodic trends also help us to explain these properties as well. Okay, so what you're going to do now is you are going to, on the last table there, you're going to summarize these trends all into one handy dandy table. So you have this table on the last page of your packet. Going across a period and going down a group, you're going to list the qualitative periodic trends, the periodic trends that have numbers associated with them. And that will be your atomic number, atomic radius, electronegativity. For each trend, you're going to identify whether it increases or decreases as you go across and down. Now for the qualitative trends, remember, which instead of going straight across and down, they're going from corner to corner. So for these trends, you're going to identify whether the metallic or non-metallic character, and reactivity, whether those increase or decrease as you go across. So you're just going to summarize what you have learned so far. All right, that's it for this video. Have a quality day.